Hello. Everyone's entering the class now. Still got a lot more to go. Okay, let's see. Pretty close to most people are here now. I'm gonna go ahead and switch to screen sharing. Okay. You should see my desktop now. Everybody, oh, let me check. Everybody hear me? And you see the desktop? Everything look okay now?
Yeah.
Yeah.
Okay, great. Thank you. All right. I think everyone's pretty much here by now. Okay, so here's what we're going to do today. Okay. You've got a new reading assignment for next week. Today we're going to talk about this reading assignment here. So we're going to be talking about chapter 3. And we're going to start next week with chapter 4, which is an important chapter. It's something called methods, which is one of the real important ideas in programming. One of the most important most important ideas in programming, this idea of methods. So we'll be spending next week talking about that. Okay, and let me show you something else. You have a homework assignment. We talked about it on Tuesday. The homework assignment is what you get a grade on. Okay, but I also want you to do homework problems for practice. So here is some homework. This here is a homework assignment for practice. So let me just show you what I mean. This one book one of the two textbooks we're using has lots of problems in it, and they're really good. So like this book has a whole page of these mixed up code problems, the problems where you have to drag and drop code from over here to get it in the right order, okay? And this page has got, let's see, if you go to the bottom, there's 14 of these problems on this page, okay? These are very good problems. They're a real good way to practice thinking about Java. I want you to do as many of them as you can, but I ask you to do these 4. You should do those 4, at least. If you find them real easy, you probably don't need to do many more. But if you're still unsure and you're finding it difficult to do them, keep on doing more of them. They're a very good way to get yourself used to the Java language and the way we work with Java. So do at least those, okay? And then
I have a question.
Yeah, sure.
How again do you check for the number of characters in a program?
Oh, okay. Just show you real quick. If I download the homework assignment, unzip it. Remember, if you just right-click on a file, so that's right-clicking with your mouse, then go all the way down to the bottom and click Properties. Windows tells you how many, they call them bytes, but that's how many characters are in the file. Okay.
Well, how do I check my own?
After you've written it, you right-click on your file and check it.
Oh, I got you.
Yeah. See, so like that's right now, before you put anything into that file, it's got 93 characters in it. Okay. So that's the file before you put anything in it. That's the version I gave to you. It's nearly empty, but it has just the standard stuff here. So that's 93 characters. Then you'll put more code in there. And then, for example, the long one starts out as 2,581. Okay. So after you put your code in here, if when it's working, you can check if it's short enough yet by measuring it. Windows measures it. Windows counts the characters in it for you. So after you have to save your work. You open the file in Dr. Java, do your work, make sure you save it to the hard drive, and then ask Windows to tell you how many characters are in it. Okay. Oh, here's the picture by itself. The picture itself, just the picture is 1,500 bytes. And now the long program has more than that because it's got all the Java code that has to print that picture. Okay. So the Java code and the picture combined is 2,500 bytes. The picture by itself is 1,500 bytes, but you're supposed to get a program that prints that picture in under 600 bytes. Okay. What about other questions about the homework assignment? Anybody else have a question about this homework assignment? Okay. Yeah, if you have questions as you're working on it, send me email. So if something comes up and you're not sure, just send me an email. If you want, we can always meet with Zoom, or you can just get, you can maybe, if the question is not too complicated, you can answer it by email. If you need more if you want to ask a bunch of questions, we can meet by Zoom. Okay. Anybody else? Okay, so that's good. Okay, all right. So then, like I say, you have this. Okay, there's the first homework assignment, which is the mixed up code examples. Do a few of those. This other page from that book has what are really more like real programming problems. You type code into a window and then you run it, and then they tell you whether you solved the problem. The problem will be described up here. Now, some of them you type the code, some of them you have to modify the code that's there or find a mistake that's in the code that's there. So there's a bunch of different kinds of problems. Some you either modify the code or find a mistake in it. Sometimes you just add something to the code. Sometimes you, like here, that's a comment, so you have to add the code yourself. Okay, so these are a little bit harder than these. These, the code is written. You have to just read it and figure out what order to put it in, and you have to figure out which lines don't belong. So they always have some code in there that doesn't belong over here. Actually not always, but most of the time, there'll be something over here that doesn't belong over here. So you have to read these and drag and drop them into right order. So you're building a program kind of like a puzzle, okay? Over here, you actually usually have to you have to either write a program or you have to read the code and modify it to make it right. That's a little bit harder. So over here, I asked you to do 3 of these problems. I thought those were good ones. If you find them, if you think that they're really tough, do a few more. These are, learning to program is a lot like learning a foreign language or learning math. You can't learn to speak a foreign language unless you speak it. You can't learn to program unless you write code. You don't learn math unless you solve math problems. One of the beauties of these books is that they let you solve homework problems and get immediate feedback, which until a couple years ago, we didn't even have this available to us. This is really kind of nice for you to have homework problems that you could do and get immediate feedback on. Okay, so this is really great. This is a good way to learn. So this book, more so than the other book only has a few problems in it. This book has lots of problems in it. This page has 17 problems, and this other page has 14 problems. Like I say, do as many as you can. Keep doing them until you feel very comfortable with them. But I ask you to do, I think everyone should do those 4 and these 3. If you can really just do them without any effort, fine. Just go on and go work on another class. But if these seem challenging, keep working on them. That as you do more of them, you'll start getting used to what Java asks you to do and how we program in Java. Okay, so this is homework. It's not graded. You get feedback. You get immediate feedback. You're told if you're right or wrong. It's not for a grade. It's for practice. Okay, and the other homework is the homework for a grade. Okay. If you have questions about these problems, again, just like anything else, if you have questions about these problems, like if you have trouble solving one or don't understand their clues or their hints, send me an email. Okay, so if you have any kind of questions, please ask. Okay, all right. So that's the first thing I wanted to talk about was that over the weekend, that's besides doing the programming assignment, do these practice problems. Okay, and then let's see. Well, let's start talking about the reading that was for today. The reading for today was to read this chapter 3 from one book and It's about something called the scanner. And the other book also had a section on the scanner. So that was this section 1.4.6. We're going to go over both of them. Okay, so we're going to go through both of these, and then we're going to use their code, and then we're going to use the code in this book, and then use the code in this book, and then we're going to switch to Dr. Java and see a little bit how it's a little bit different. So what we're doing is we want programs to be able to get input from a person typing at the keyboard. So this picture illustrates the idea. You've got a Java program, that's this guy here, and we've got programs that print output. You know, the output shows up usually in a window down below here. Like over here, the output shows up on the right-hand side over here. So we've been doing programs that send output to the user. Now we want to start having programs that can do input. How does a program get input? And right now we're going to get the input from somebody typing at the keyboard. Later on, we'll see you can get input from a file on someone's hard drive. You can get input from an internet connection over the internet. You can get input from a database. Okay, some of that, like, we're not going to use a database in this class, and we probably won't use internet connections in this class, but we will use files. We'll see how to get input from somebody typing at the keyboard, and later in the course, we'll see how to get input from files stored on a hard drive also. So we want programs to get input, to get data from somewhere. The nice thing about that is eventually you'll be able to write programs that work with massive amounts of data. Once the program can get its data from a file, and you don't have to have somebody typing the data into the program, you'll see how computers really work. Computers work with massive amounts of data because they get their data from internet connections and databases and files. But we're going to start with something real simple, just having somebody typing at the keyboard. Somebody typing data at the keyboard. So that's our first goal. That's what the scanner class does for us. Okay. So the scanner class is something that's built into Java. The output, we don't have to do anything special to get output. We just do system.out.println. Input's more complicated. Input is more complicated than output in general. Okay, it's more complicated to get data in. For some reason, it just turns out to be more complicated to get data into a program than it is to get data out of a program. So to get data into a program, you need something called the scanner. Now, to use a scanner, the first thing you have to do is tell Java you want to use it. So you need a new kind of line of code here. Notice that this line of code is before your public class statement. It's a special kind of code that sits outside of the rest of the program. It has to be the first line in your program. You say that you're going to import the Java utility scanner program. Okay, so you're using a part of what's built into Java, but you have to tell Java that you want to use it. Okay, so that's the first thing you have to do. If you want to get input, you have to put that line of code in there. Then you have your class name. Then you have the public static void main string. Then you need another line of code that we need to get input. We need still one more line. We have to create a variable called a scanner variable. So you pretty much type this line. Later on, we'll learn a little bit about how to read this line. The key idea is that we're creating a new scanner tied to the keyboard. The system.in is what Java's way of saying keyboard. Similar to system.out is Java's way of saying where the output goes. System.out is where the output goes. You print to where the output goes. And we're going to read from where the input comes from. So system.in is the keyboard. So we create a variable that represents the scanner that's reading from the keyboard. So we need a line of code like that. Once we have a line of code like that, we can ask the scanner to read a line of text from the input. So that's what this looks like. Now, what this program is doing is it's telling the user, please enter your name. So it prints to the user a message. Please enter your name. Then the next line of code actually reads from the scanner whatever the person types in. So this line of code actually waits for the person to type something. So this line of code waits for the person to type something. When the person has typed something, Then this thing puts what they type in that string variable, and then we print out what they typed. Now, input is tricky, and this website can't actually use the keyboard. The people who wrote this website, again, they didn't seem to either want to or know how to get their Java program running in this web page to use the keyboard. So they cheated. The input that would come from the keyboard actually comes from this box here. Okay? This box here is actually where the scanner gets its input from. It doesn't actually get it from the keyboard. So system.in in this program is actually this box. So if I run the program, it says, hello, Fred Smith. Now, if I want, I can change what's in this box. And I can rerun the program, and now the scanner will read from what's in that box. Now, notice that the scanner is getting data that's not inside the program. So we still are reading data from outside of our program. The data is coming from outside of the program. Not quite from the keyboard yet, but because keyboards are tricky, they cheated and they created a little box, and the program gets its data from this box. So if I run the program again, see, now it says, hello, Fred Jones. I can change that to anything I want. Now it's going to say, hello, class. Okay, see, so the program printed out this message. Please enter your name. Okay, that's the message from the program. Normally, that would be a prompt to the user that it's time to start typing something. In this case, the program doesn't wait for anyone to type anything. It immediately goes to this line, and it reads the line of input that the person types. So we call the next line, we call this a method. Now, for now, you're going to get used to typing code like this. This is what reads one line of input from what the user types. So the name of the scanner, scan, and the name of the instruction to the scanner to say read a line of input is next line. Okay, so you read that reads a line. It stores it. See, the equal sign stores things in variables. So what this thing reads is stored in that variable, and then down here you can print what was in that variable. Okay, all right. So there's an example of using a scanner. Okay, now here's a very similar program in the other book, but this one works a little bit better. These people figured out how to get their web page to talk to the keyboard. So theirs actually works a little bit better. Okay, so now now here's that first line that has to tell Java we're going to use a scanner. Then they have their class line. Then they have the main method line. Okay, then they create a variable to hold what they're going to read. Okay, they created the variable first and then fill it in later. Okay, so they declared the variable first, then they filled it in later. That's okay. Over here, they declared the variable and filled it in at the same time. I actually think that's better. That's a better way to write it. It's better to declare a variable when you're filling it in. This idea of declaring an empty variable and then later on filling it in is usually not considered a great way to write program. So if I was going to improve this, I would comment out that and declare the variable down here. Same. That now it's more like the other one. And this is actually a little bit better way to write the program. You should declare a variable when you need it, when you're going to fill it in. It's a little bit, it's kind of weird to declare the variable up here, leave it empty, then fill it in down here. Okay, so that's actually not the best way to write the program. So after their class, then they say, okay, here I need a scanner. Now notice they gave their scanner a different name. You can name variables any way you want. They named their scanner scan. They abbreviated the word scanner. They named their scanner in because it's getting input. Both are good names. Okay. So they named their scanner in. Then they print a prompt to the user, type something. And then from their scanner, see, they're using the name of the scanner, they tell their scanner, read the user's line of input and store it in that variable. Then they print out that variable. Then they do something the other example didn't do. They ask for more input. See, you can use a scanner many times, and you don't create another scanner. When you want a second input, that's actually, they should have shown that over here. If you want a second input from your user, you don't create a second scanner. Scanner can be used over and over again, okay? So here they're prompting the user, type something else, and then from their scanner, they read in more input and store it in the same variable that overwrites what was stored in the variable this time. Okay, so this variable is holding what was read in this time. Then you overwrite what was in that variable with the new input and then print out the new input. Okay, so let's run this and see how it works. Okay, now see it said type something and then there's this blinking cursor. That's this program waiting. It's actually in line 10 right now. It's here waiting for input. Okay, so this program is waiting for the user to type something. So I'm going to type something. Okay, and it's still, the blinking cursor is waiting for me to type more. Or maybe I decide that I don't want to type more. Or maybe I decide I wanted to say something else. See, what it's doing right now is it's waiting for me to decide when I'm done typing. And I can type, erase, type some more, change my mind again. Okay, type some more. Now I'm done. Now here's how I tell it I'm done typing. I hit the enter key. When I hit the, you'll hear it. You don't really see me do it. You'll hear me maybe on the video in your speaker. I'm going to tap the enter key, and that's the signal that I'm done typing over here. When I was done typing, then this thing read what I typed, stuck it in this variable. This line printed out what I said. You said, this is interesting. Then it prompted again, type something else. And it went back to the scanner and said, okay, read something else from the user. And now I got the blinking cursor. And like again, the cursor's waiting for me to type. If I decide I type something dumb, I can go back. I can type something. I can type something, I can go back and change. Okay, all right. I can even use the arrow key to go back and forth. Okay, and what's interesting is I don't even have to be at the end of the line here to type enter. I can actually, I can use the arrow keys to go back and forth in here, make changes. Whenever I'm done, I can just hit the enter key. Okay, so when the program's waiting for you to type, when the program's waiting for you to type, you actually have the control of the computer, the keyboard. You can type, use your arrow keys, go back and forth, delete things. When you hit enter, that's your signal to the Java system that what you typed is what you want, that you're done. Okay, all right. So this is a little bit nicer than this one. This one was stuck getting its input from a box, which isn't very realistic. Okay. This one can at least prompt the user, and the user can really type in. Okay. Now, let me do something. Let me copy this into Dr. Java. Let's see how this looks in Dr. Java. It's going to look a little bit different in Dr. Java. So I'm going to copy this. I'm going to start Dr. Java. Dr. Java works similar to this website, but not quite 100% like this website. Okay. So we want to see how this code works when we run it in Dr. Java. So I'm going to paste it into Dr. Java. Okay. Now, on my computer using Dr. Java, I have to save that to my desktop and compile it to my desktop, then run it from my desktop. When you're working on these web pages, you never see this thing stored as a file, and you never see it really compiled to a class file, because that actually happens on the computers of the people who own this website. You actually are not programming on your computer. You're actually programming on their computer, and their computer sends back to you the results. The Java program actually runs on their computer. Okay, that's the way it works. Okay, so whatever you type here gets copied up to their computer, saved on their hard drive, compiled on their hard drive, run on their computer, then the results are sent back to this window here. If I'm working on my computer, I have stuff stored in Dr. Java's window, but I have to save it to my desktop. Dr. Java knows what name to give it. Since the class is Echo, it saves the file name Echo. Okay. So there's Dr. Java saved my file right there. Okay. Now I have to compile it. Dr. Java created the class file. Now Dr. Java can run the class file. So now we want to run the program and see how it works. Okay. In Dr. Java, when the program is waiting for you to type input, it shows a little box. Okay. See, it's got this little box. Okay. And this little box is where you type anything you want. And you can you can use the cursor, you can move around, you can backspace over stuff. And then if you want to, you can move around. You can leave your cursor anywhere you want. And when you finish, you're done. You just hit enter, tap enter. Okay. You said hello, everyone. Okay. Then, remember, it prompted for the input, read a line of input, echoed what was read in, then it prompts for another line of input, reads another line of input, and echoes that. Okay, now I'm in the second line of input. Okay, so type some junk, hit enter. Okay, now let me make a little change in this program. Change that print line to print. You see something a little bit interesting. Let me save the changes, compile. Well, actually, let me go. I'm going to change it again. I'm going to put back the ln there and remove it from there. Make it easier to see what we're talking about. So I'm deleting this little ln from that print. Save my changes, compile my program, run it. Okay, there's my first box. Now notice my second box. See, it's not below the prompt, it's alongside the prompt. Here, the ln meant type this line and then go back to the beginning of the next line. So then when I give the user the box is on the next line. Okay, some people do it that way. Some people like to do it this way. See, this prints and there's no new line here. So after this is printed, the box ends up on the same line as that message. And some people think that looks a lot nicer to have it that way. So then please enter something, and you're entering it alongside of the prompt. Now let's go, okay. So that's a little minor thing, but if we go back to the website, we can see how it looks like in the website too. So get rid of this ln here. Okay. Now this one, the prompt is on the line below the user will type in below this line. Here, the user will type in alongside of this line here. So let's watch, see how it looks. Notice that the prompt is below the message. Notice how the prompt is alongside the message. Actually, it looks better this way. Type something else, and then there's the prompt, okay? So this is a little change, but it's kind of nicer looking. You prompt the user, and then they type their message, they type their answer right next to what you're prompting them for. Okay, it's the difference between print line here and print. Okay, and then I go back over here and hit enter. Whoops. hit enter, and there's my output. You said goodbye. Okay. All right. Now, let me do something, and a little experiment here. Run this program. Notice it's blinking, waiting for something. Run this program. Where's run? Oh. It's blinking, waiting for something. I've got two programs that are running on my computer. Both of them waiting for me to type. Okay. If I type, who gets my keyboard? You know, there's two programs waiting for me. If I were to type right now, who gets what I type?
Dr. Java?
Why? Now, why would Dr. Java get what I type? How do you know that?
Because it's blinking.
It's blinking and the other one's not. Now watch. Suppose I go over here and click on this window. Notice that Dr. Java stopped blinking and now this guy is blinking. Guess who gets what I type now? The one that's blinking. Like watch this. Notice I can alternate between them. This is called focus. I'm switching the focus of the keyboard from one program to the other. When I click on a window, that window gets the keyboard focus. And you can see that the cursor blinks to let you know that where the focus is. Then when I click on this window, the keyboard blinks to see that I have focus over here. I can do another window. Let me bring up a little command window. See the blinking? That blinking means that he would get anything I type. Okay. Now if I go like this, see he's not blinking anymore. Now my keyboard focus can go to him. My keyboard focus can go there, or my keyboard focus can go there. Okay. Whichever one I click on gets the keyboard focus. Okay. Now, to show you how kind of subtle this is, let me do something else. See how I'm scrolling this window up and down? Okay. I go over here, and if I go like this, I can scroll this window up and down. And I can go over here, and I can scroll this window up and down. Now watch something subtle. He has focus. So he's got the blinking cursor. But if I go over here, he still scrolls. Scroll focus is different than keyboard focus. Scroll focus is called focus follows mouse. Like watch, if I put the mouse right here, see it's between, look who scrolls. Now I'm using my mouse wheel. So my mouse wheel, I don't have to click on that window for that window to catch the mouse wheel. The mouse wheel affects whatever window the mouse is floating over. That's actually new in Windows 10. If you actually had a copy of Windows 7 or Windows 8, it didn't act that way. In Windows 8, the scrolling was just like the keyboard. You had to click on this window to make this thing scroll. And you had to click on this window to make this thing scroll. You had to click on this window to make it scroll. And then Microsoft decided that it would be nicer, and I agree with them, it's way nicer to have the scrolling follow not where you clicked, but where the mouse is. Now, to show you how different computers are, the Linux operating system, the keyboard acts like Windows scrolling does. On the Linux operating system, if the mouse is over this window, anything I type goes into this window. This window would start blinking. I don't have to click on the window. If the mouse is over the window, then you're typing into that window. So even like this window here, which is in the background, if this was a Linux machine, if I put the mouse over here and I started typing, I'd be typing into this window, even though the window would stay in the background because I didn't click on it. That's not considered such a great thing. It takes, that's Linux's choice, and it's been that way for a long time, but a lot of people change it to act like Windows anyway. I think Windows has it the right way. For scrolling, focus follows mouse, but for typing, focus follows what you clicked on. It's the front window that gets focused. See, I have to click on that window to be able to type there. I have to click on this window to be able to type there. Okay. As we go through this semester, we're going to learn a lot about what are really technical, little, subtle aspects of how computers work. If you're learning how to program, you should learn how computers really work. Yeah, I think you should all become really knowledgeable of subtle things about how computers work. And programmers need to understand focus. It comes up pretty often. Programmers need to know how keyboard focus and how mouse focus work. And on Windows 10, mouse focus follows the mouse. Scroll focus follows the mouse. I'm not clicking on anything. But keyboard focus follows what I click on. I have to click on a window to get it to get keyboard input. I have to click on a window to get it to key, and that puts the window in front. When you click on a window, the window becomes the forefront window. So typing is always into the window that's at the front. Typing is always the window that's in the front, not on Linux, but on Windows. But on Windows, scrolling is whoever your mouse is over. So this window's 2 windows back. This one's in front, this one's next, this one's the third, this one's back. Okay. Notice that the menus also follow the mouse. Notice how that menu, in older versions of Windows, if I hovered over that menu, nothing would happen because that window's in the background. It's not the front window. So the menus kind of act like the scroll. If you hover over a menu, it affects the menu, but that didn't happen on older versions of Windows, but it happened. Now, that menu doesn't do anything unless you click on it. As soon as you click on it, then you're shifting focus over to that mouse, that window. So it's kind of, the menu is a little bit odd because it's not clear why you'd want the menus to be activated when you don't have a window in the front, because you can't do anything with those menus. To click on them, you bring the window to the front. But the window doesn't have to have focus for you to see what's in the menus in that window. Okay? Okay, these are little details of programming that as we learn to program, we'll pay attention to details like this. Most people don't know what focus is, but programmers should know what focus is. Because if you don't, you'll have a hard time writing programs, because programs have to pay attention to these things. For example, take Dr. Java. Right now, if I type, I'm typing in here. But if I type now, focus is up here. See, Dr. Java has its own windows, and focus can be up there, or focus can be down there. Okay, so the people who wrote Dr. Java had to be aware that the focus could be on this window or this window, and they had to deal, they had to write the code to deal with that. Their code has to be able to simultaneously get keyboard input in this window, at the same time it gets keyboard input in this window. Their program is reading from the keyboard at 2 places simultaneously, which is something you learn how to do eventually, how to do that. Our programs won't be able to do that. Our Java programs will only be able to read from one place. The program will have only one place where it can get input from. But real Java programs can have many places where they get input from. They can actually, there's another, let's see. Right now I can only have 2 windows. I can have, Dr. Java can get input in this window, or it can get input in this window. So right now I could get input in 2 different windows. It could get a third window. If I did something like this, if I pulled up the preferences window, it could get input now here. So now that's a third place where it's but the thing is, Here's another interesting detail. I can type there. Can I go back and type here? It won't let me do that. Watch. When this has got focus and I type in here, I cannot switch focus over to here. This is a special kind of window. It refuses to share focus with any other window. If I try to click over here, this window complains. It's not gonna share focus. These two windows share focus. See, I can type there or I can type there. A window like this that doesn't share focus has even got a funny name. It's called a modal window. They're called modal windows. I don't know where they got that name. Okay. See, you read about them in Wikipedia. It's a user interface concept. Okay. Modal windows don't share themselves with anybody else. See, like this, how I can switch between that, and I can switch there, and I can switch over here. But once I switch to Dr. Java, Dr. Java's forcing me to go to this modal window. This part of Dr. Java won't let me do things. It won't work. Like I can't copy, I get weird. Oh, let's see, it's kind of, oh, it's working now. Oh, because I hadn't typed anything in here yet. See, what I typed in here disappeared. See, now it won't let me type over here. It doesn't want to just share. It doesn't want to share. So it doesn't like, what I typed there is illegal. So it immediately checked this before it would let me type over here. Okay. So modal windows are different. Modal windows don't share themselves like these kind of windows do. Okay. Okay. Some modal windows, when they pop up, they can't even switch to another. Like Dr. Java's modal window, I can switch between this window and this window. Usually, you can't even switch between the windows. Like here, it won't share the keyboard input, but Dr. Java will let me switch between them. Usually, when you have a modal window, you can't even switch between the two of them. You can only, once the modal window's popped up, it blocks everything behind it. Okay, these are the kind of things we'll be learning about. Different ways that the computer works as a user interface. So we'll just start seeing, and you can start paying attention to these things. You'll start seeing them. Oh, I don't know if I can bring it up anywhere else. Like here's a pop-up window. See, I cannot go back to the, see, this is a true modal window. I cannot go back to that window behind it. I can go to other windows, but I cannot go to this window here. This, as long as this guy's popped up, he's blocking that window he came from. So I have to click cancel to go back to this window. So that's a good example of a really modal window. Once it pops up, it gets input, it has focus now, and I can't, oh, notice the scroll focus still goes over here. So he's got keyboard focus. The scroll focus still works here, but I cannot click on that window. I don't know if you hear it, but I'm getting a little bleep from my computer telling me that's an error. I don't know if you might barely hear the little bleep. Does Zoom here? Does Zoom pass those error bleeps along to you? Zoom has a real weird interface. No. Pardon me?
Hear it?
Did you hear the error bleeps?
No.
No.
Oh, okay. So see, Zoom isn't passing them along to you. It's weird. So that's a good example of a user interface design. Zoom seems to somehow think that when I see certain error things, you shouldn't see them. So like, I'm getting an error bleep from my computer, meaning you can't click on that thing, but Zoom isn't passing it along to you. I wonder if I turn up the volume. Do you hear it?
Yeah, I heard
Yeah,
it.
it comes through real faint.
They're real faint. Oh yeah, because so it's somehow maybe it's just the microphone's not picking them up. So it may just be the microphone isn't picking them up. So you can do it yourself. you bring up one of these command prompts. You click up here, CMD, command prompt. You right click on the command prompt. Its properties is a modal box. And you can't, it has focus. You can click here, you can type in here, you can type in these things. There's some places where you can type, but this one you can scroll still, but you can't go back and type in this guy. You get the little bleeping error message. Okay, so as we go along, I'll try to show you how things we're learning as programmers are parts of the user interface of Windows. Okay, all right. Now, let's keep on playing with scanners. Let's look at some other stuff that a scanner can do. Okay, let's see. This program that was his first input. That's his second input. Okay, also I can just give it blank input. Let me just run that again. When you're asked for input, you don't have to give it. When you're asked for input, you don't have to give it. These are now empty strings. I just hit enter. I didn't type anything. These were empty strings, so they printed out emptiness. Printed out emptiness. Okay, so you don't have to type something. It's not an error to type nothing. Okay, now my program might complain. I can write this program to complain if you type nothing, but my program would have to check if this variable is empty or not. And we'll see how to do that. As we learn more about program, we'll see that I could check that you actually did type something. And if you didn't type something, I could say, please type something. Oh, yeah, I could ask you to type it over again. But right now, there's nothing that requires you. The scanner, when you ask the scanner to read an input, the scanner doesn't really care whether someone types an input or not. So again, here I type nothing, but here I can type something. Okay, so there was nothing typed into this box and there was some junk typed into this box. Okay, let's look at some other things you can do with a scanner. You don't have to read whole lines. You can type in, watch this. I can ask the user to type in an integer, but then I don't ask for a next line. I ask for next int. But then I'm not reading a string, I'm actually reading an int. The scanner will read in an int for me. Okay? All right, I'm going to still call it line, kind of dumb name for an int, but I'm going to call it line. Okay, so compile. Whoops. Oh, but down here, I'm going to call this. See, down here, I changed. This one is still a string, so I have to give that a different name because down here it's really is a string. Up here, it's going to be an int. So down here, I'll say string, and here I'll go ahead and call it x. Or n for int. All right, so read in an int and call it n, print it out, and then ask them for a line. So compile, run, type in an integer. Okay, you said 12, type in something else. Now, how do I know that's really an integer? Okay, I mean, watch this. Let me go back. Well, actually, let me run it again. Twelve. Is this 12 anything different than this? Let's see. Oh, what happened? Let me run that something. Oh, I remember now. It's a little bit quirky right now, what's happening. 12, hit enter. You said 12. Notice my program just ended. Type something else. You also said you know, things got messed up. We're gonna have to study the logic of the scanner. The program, notice I didn't get a second box. I did not get a second box here. It's one of the things we're gonna have to sort out is what's going on here. So let me change this program. I want to show you that this really is a number. So let me change this to type in a decimal. And now if it's a decimal, I'm going to ask the user to type, I'm going to do this, double X, read next double. Okay, so I asked the user for an int, read in the next int. Print line, you said that was their number. Then system.out.print, type in a decimal. Okay, then I have a variable to hold what I read in, but it's a double because the scanner will read what they type and give it to me as a number. Then, okay, so now if I compile this, oh, what did I do wrong? Oh, I forgot to change this to X, okay? Okay, type in an integer, 12. Type in, you said 12. Type in a double, 23.4. You also said 23.4. Here's how I can see that those are really numbers. I can do arithmetic on them. Okay. So I'm gonna take the numbers that they did and do arithmetic on it because they're really numbers. They're not strings like when we did next line. The scanner gave me back the number they typed in. Okay. So I type in a number like 10, and I can type in a number like 2.5. And it added them to get 12.5 because it got back numbers, okay? Now, let me change this program a little bit. So I'm gonna create a version 2 of Echo. So I'm gonna copy this, new, save, Echo 2. And Echo 2 is actually I should have called the other one Echo 2. I'll call this one. I'm going to make this one go back to the way it was. Please enter. Okay, and this is going to be back to string. Call it S for string, and this is next line. You said S. S. Take me a little bit to type all this back out. I want to compare these two versions. So okay, now I'm calling this Echo 2, so it's a different program. Okay, now run Echo 2. Type in a sentence, 12. You said 12. Type in I should have changed that to type in another sentence. Type in 2.5. Now notice that you said 12, you said 2.5. It doesn't look any different than this one, which is reading numbers. Like now run this one. Type in an integer, 12. Type in a decimal, 2.5. Okay. Notice that I can't tell from this output whether this was read as a number or read as a string. They look alike. And this is a very subtle thing. when you type at the keyboard, when you type, the keyboard doesn't know if you're typing a number or a string. I typed the characters 1, 2 here. Here, the characters 1, 2 were read as an integer 12. But in this program, when I type in 1, 2, they're read as a string where the first character is a 1 and the second character is a 2. In general, we're going to have one of the things you're going to have to really get used to is something like that in Java is not going to be the same thing as that. And something like that is not going to be the same thing as that. That's a number. That's a string whose characters are the same as that number. But this is not a number. You can't add this thing to this thing. Well, you actually can. Suppose I give these names. Suppose I say that A equals 12. Okay, I'll call it A1 equals 12. A2 equals, okay. Suppose I have down here B1 equals 2.5, but B2 equals that. Okay. What is A1 plus A2? What's 12 plus 2.5? What's the answer?
Would it be 12, 12?
Yeah, and I'll write it this way. You get here 14.5. Okay, did I do that right? Yeah. Right. So this is a way of saying that this thing, it evaluates to, or it becomes 14.5. Now here's an interesting question. What about B1 plus B2? What does, if this is Java, I can do this in a Java program. Maybe I should turn it into Java. But it's a question. What happens when you add strings?
Would it be 2.5, 2.5?
No. Careful. B1 plus B2. You're almost right. What would it be? No, wait a minute. I'm sorry. You're right. Wait, I meant to say what? I typed the wrong thing. I meant to say A2 plus B2. I'm sorry. See, first I added this number to that number. Now I want to add this string to that string. So I was dumb. I typed the wrong thing. So that's A2.
Is that first one A1 plus B1?
Yes. Oh, I see. It's hard to talk and type at the same time. You're right. That was meant to be A1 plus B1. Add the numbers. The first line was add the numbers. The second line is add the strings. So the first one is add the numbers. You get this. What do you get if you add the strings?
122.5.
Well, but as what?
String?
As a string. So it's actually not the number, it's that string. Because adding strings just put them next to each other, which is not what you mean by addition. It means it's what we call concatenation. So, we would call this one, this is really addition. This one actually is called concatenation. Okay. This is going to be something that's going to cause a lot of trickiness in Java. It's not the same thing to talk about the number 12 and the string 12, the number 2.5 and the string 2.5. If you add numbers, you get arithmetic. If you add strings, they concatenate. Now, I can also do some kind of weird things. What if I do A2 plus B1. I don't even know if the book has told you about this yet. I don't think it has. On the left is the string 1, 2. On the right is the number 2.5. What happens when you put a number to the right of a string is that the number is converted into a string. And you get the same thing we got over here. No, I see. I'm sorry. This is, yeah, we got the same thing we got over here. So notice that I have a string first. So the first thing is the string 1, 2. Then I add to it the number B1. The rule in Java is that when you add a number to a string where the number's on the right and the string is on the left, you just take the number and convert it into a string. On the other hand, what if I flip them around? What if I take the number A1 on the left and add the string B2 on the right? This is a mistake. Java won't accept this. It won't convert the number on the left to a string. It only converts the number on the right, I think. I actually should check it, but I'm pretty sure this one gives you an error. It won't convert the number on the left to a string. It only converts the number on the right. So there's all kinds of weird things going on. There's a difference between a number and a string that represents that number. Now, Scanner has a big difference between reading in a string and reading in a number. When Scanner reads in a number, it converts the string you type. Right here, you're typing characters. It takes those and converts them into a number for you. So it does the conversion, and you end up with a number here. If you use next line and somebody types in a number, you get the string value of that. You get the string that they typed in. You get quote 1, 2, quote. And this is tricky, and it confuses a lot of people because when you type it, you type the same thing. When you type 12, you have to look at the code to see what's happening. This guy reads 12 as a string. This reads 12 as a number. This reads 2.5 as a number. This reads 2.5 as a string. And things get even a little bit more confusing than that. Like, let me go back over here and run this one. It's asking for an integer. Suppose I type 2.5. Some programming languages, not Java, would take the 2 out of this because you asked for an integer. So it reads the 2. Java blows up because you didn't type an integer. It will now. This is not all languages agree on what to do here. I asked for the user for an int. The user typed 2.5. Some programming languages will say, well, there's a 2. That's good enough for me. That's the int. And it'll ignore the 0.5. Java says the user typed in 2.5. They were supposed to type in an int. 2.5 is not an int. We blow up, which can cause, you have to be very careful about this when you're programming. So when you ask for an int, the user has to type in an int. Okay, let me run it again. Here's a more extreme example. Type in an integer, dog. Program blows up. That's maybe not so unreasonable. There's no way to turn dog into an integer, so the program blows up. It's asking for an integer, and it really doesn't know what. See, it cannot put into n anything but an integer. It doesn't have a clue what to do with dog, so it blows up. The more subtle one is when you give it 2.5 or 12.0. That sure looks like an integer to you and me, but not to Java. It will not accept that as an int. It really wants an int here. So when I hit enter, this thing's going to blow up my program. My program, notice it blows it up in a kind of spectacular way. You get a 50-line error message. It's just, and nowhere in here, let's see. Give you an example how hard programming is. You asked for an int and you were given a double. So you might expect the error message to be, you asked for an int, but you got a double. But if you look, the error message, the closest thing there is in there is mismatch. That's a mismatch because you asked for an int, but you got a double. If you read the rest of this, it's just gobbledygook. Okay. The only hint of what really went wrong is the word mismatch here because you mismatched int and double. Now, how hard would Java be to say you asked for an int, you were given a double, so you got an error message down here? Unfortunately, computers are not as smart as we think they should be. Error messages are where you really see how dumb computers are. They give you really dumb error messages, which can be sometimes pretty hard. First of all, why is the error message 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 34? Why is it 15 lines long? Okay. There are good reasons for a lot of this, but as a beginner, it's kind of weird that you make a simple mistake, you get a 15-line error message that tells you almost nothing useful. Okay. But what's important is when you ask for an int in your program, the user has to type an int or the program blows up. When you ask for a double, things are a little bit more forgiving. Let's see. Here's my int. Now it's asking me for a double. 2. 2 is not a double. There's no decimal point in it. But Java was happy to convert 2 to 2.0. So we've seen things like that. Java will convert ints to double, but it won't convert doubles to ints. Okay, it will not convert, like it won't convert 1.0 to 1, but it will convert 0 to 2.0. So if you ask for a double, now there's my int. If I type dog here, blows up. Dog is, there's no way to turn dog into a double. Okay. Now, here's something that confuses people a lot. Watch this. Got another minute or two. Let me show you one other example. Double dog equal 2.6. Okay. Compile my program. Run it. Type an integer, 1. Type a double decimal, dog. Dog's a double. Do you think this will work or not? Take a guess. See if you can come up with a explanation. Dog is a double with the value 2.6 in my program. Down here, Java's asking for a double, so I type dog.
It shouldn't, right?
It doesn't work because this is not inside my program. This is actually outside my program down here. This DOG is just a string. It's not that variable dog. So watch. I hit. Now this actually, a lot of people expect this would work. And it works in some calculator languages kind of work. But here, dog is just a string. It's not the variable dog from my program. It might look reasonable to see dog is 2.6 up here, so dog should be 2.6 down here. Java doesn't work that way. When you ask a scan, here's what you should think of. Go back to this picture here. Oh, God. Dog is not in my program. Well, In my program is a variable called dog. What I type is out here. It's not in my program. So when DOG gets sent to here, it's not being sent as, here's the variable dog. It's being sent as a string, the letters DOG. So when my program reads the letters DOG from here, it goes in here as the string DOG, which is not the variable. Because if you look over here, this is not a string. It's a variable with the letters DOG in it. This is actually a string with the letters DOG in it. That string does not come back here and go into here. It's actually a common mistake in this course for students to think that they could type a variable down here and that they could type a variable from their program down here and it would work. If you've ever used languages like MATLAB or Mathematica, they're very different programming languages. They tend to work this way that you can have the variable is a variable, and if you declare a variable up here, it's a variable everywhere in MATLAB or something like that. Java's different. Java, C++, they don't work that way. This is coming from the outside world. We think of it as this picture here. The data is coming from the outside world. It's just a coincidence that this data happens to be the same string of letters as this variable name. So you can't use a variable name in here, over here, okay? There's all kinds of funny little, once you start doing input and output, all kinds of funny little issues come up and it can get pretty confusing. Things like, if you ask for an int, you better get an int or your program blows up. If you ask for a double, you can give an int, ints can be converted to double, but you better be given a number, otherwise your program blows up. You can't type variables down here. Even if your program has variables in them, they don't have any meaning down here. What you're typing down here are just strings. But those strings can get converted to numbers if you use next int and next double. So the strings you type down here, next int and next double know how to convert them to numbers. So that string, it's right now, I'm typing from the point of view of this picture here, I'm typing a string. The string is quote 1, 2, 3, 4, 5, close quote. But that string is going to be given to next int. It knows how to turn it into a real int. As long as it can be converted to an int, it knows how to do it. Okay? Notice that when it gets printed out here, it's printed out back as a string. See, now when I print it here, it's being turned back into a string. It got read as a string, converted to an int, stored as an int, printed out as a string, but down here, it's back to being, it really is an int. It's still an int in here. So I can do arithmetic with it down here. Same with my double. When I type something like 123.456, that's the string, quote, 123 decimal point 456. The scanner reads in the string, but next double's smart. It knows how to convert the string to the double it represents, as long as it does represent a double. If it doesn't represent a double, it blows up. But as long as the string represents a double, it puts the double in here. But this thing converts it right back to a string again and prints it out. So when I hit enter, this thing converts it right back into a string and prints the string here. But down here, it does arithmetic on the numbers. They really are numbers. Then this converts that result to a string and prints out that string there. You have to keep in your head very straight where things are numbers and where things are strings. Things will change from string to number back to string again as programs flow. And sometimes they are numbers and sometimes they're strings. And we saw here, you can do funny little things. You know, that and that aren't the same thing. Number, string. So here, if I was going to make this more complete, that's int. This one's string. This one is int. This one is string. This one is a int. This one works out to be a string. This one works out to be a string. And this one I think is an error. My memory is that this one won't work. If you put a number on the left and a string on the right, it doesn't like that. But if you put a string on the left and a number on the right, it'll convert the number to a string for you and give you concatenation. So this is concatenation. Lots of rules, lots of weird rules going on here. I have to check this one. I'm pretty sure I think this one's a mistake. I don't think this one it won't turn into addition. It will not. Java will never add a string and a number and give you a number. At best, it'll add a string and a number and give you a string, but it'll never add a string and a number and give you a number. So it will not be, it'll either be an error. This is either an error or it's concatenation. And I'm pretty sure it's an error, but it will not give you a number. Okay. Okay. So we run out of time. So there's still more tricks to the scanner. The scanner's actually got some confusing aspects to it, and we'll learn more about the scanner as we go along. Here I'm using the scanner in a real simple way. If you use the scanner in a real simple way, it's pretty straightforward. Prompt the user, read something, prompt the user, read something. Let me just show you one last thing. I'll show you what the scanner can do that's a little bit weird. 12, space, 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 3.2. Notice that input served both this next int and this next double, which is kind of weird. The 12 was read into n, and the 3.2 got read into x, and there was no second prompt. That's one of the little quirks of scanf. I typed in multiple things on one line, and scanf went ahead and read them. And it did not give me a second prompt here because there already was some stuff there for it to read. So that gives you an example of how kind of funny the rules the scanner can be. And eventually we'll learn, they're not in this chapter in the book even. This chapter 3 in the book doesn't cover all the rules of scanner. So we'll learn, I've already shown you a few rules about scanner that aren't mentioned in that book. And eventually we'll learn all of them. They're actually a little bit tricky. So scanner can cause confusion because it's got a lot of rules. If you use it real straightforwardly, prompt, read, it tends to work pretty easily. But there are quirks to it. Okay, anybody got any last minute question? Any questions we have about what we've done so far today? Because we've reached the end of the time. Anybody have a question? Okay, so I'll go ahead and stop sharing. Okay, so let's see. Remember, Monday's Labor Day. There's no school on Monday, and we'll meet again, but we'll meet again on Tuesday. There is class on Tuesday, so we'll meet on Tuesday then. So goodbye. See you on Tuesday. Have a nice weekend. Nice have a nice Labor Day. Bye.